Hi, I'm Adavia and today I'll be explaining my em3 assignment.
First, I'll explain how Euler's method works using my hand-drawn diagram. This black curve you see here represents the actual solution of the differential equation, while the blue lines here you see show the approximation produced by Euler's method. We start from the given initial point. At this point, the differential equation tells us the slope of the curve. Instead of following the actual curve, Euler's method simply follows the tangent line to estimate the next point. Once we reach this estimated point, we calculate a new slope using the differential equation again and repeat the same process. By doing this over and over, we gradually build an approximation of an actual solution. The distance we move each time is called the step size, or h. If the step size is smaller, we take more steps, and our approximation is more accurate, but it stays closer to the actual curve. If step size is larger, there are few calculations, which means the approximation becomes less accurate. From this idea, we derive Euler's formula, which calculates the next value of y using the current value of y, the step size, and the slope given by the differential equation. From this question, I substitute the given differential equation into Euler's formula to obtain the equation shown here. This is the new formula I'll use in my Excel spreadsheet to calculate each new value of y new. Next, I'll demonstrate how Euler's method is carrying out using Microsoft Excel. My spreadsheet contains 4 columns: x value, y value, the gradient, and y new. I carried out the calculations using 2 different step sizes, h 0.05 and h 0.1. This is so that I could calculate and compare their accuracy. The first column contains x value. We start with the initial value where x equals 0, and each new x value is obtained by adding the chosen step size. For example, when h equals 0.05, the x value for h equals 0.1, increased by 0.1. The third column calculates the gradient using the differential equation dy divided by dx equals x squared plus 2 divided by y. For the first row, we can calculate the gradient when x equals 0 and y equals 1, which is 2. The fourth column, labeled y new, uses Euler's formula to calculate the next estimate value of y. Y new equals y plus h times x squared plus 2 divided by y. For example, using h equals 0.05, we can calculate that the value of y new is 1.2. Whereas using h equals 0.05, the y new value is 1.1. After calculating the y new, this value is copied into the next row of the y column and becomes the current y value for the next iteration. This same process is repeated until x equals 1. Finally, I'll compare the Euler's approximation with the exact solution. Starting with the differential equation, I separate the variables by multiplying both sides by y. Next, I integrate both sides, which gives me this. Using the initial condition, where y0 equals 1, I find that c equals half. Therefore, exact solution is substituting x equals 1, I get 2.38048. After that, using Euler's method with a step size of 0.05, I can get that the value of y1 is 3.390936. And subtracting that with the number I got just now, I can get that the absolute error is 0.010456. Using the same for the 0.1, absolute value is 0.022152. Comparing the two results, the approximation using h equals 0.05 has a smaller error than the approximation using 0.1. This shows that reducing the step size improves the accuracy of Euler's method.
That's the end of my assignment. Thank you.